Okay, let's now start with our first two versions. Again, for all the 5 versions I'm going to illustrate, please make sure you understand this particular starting structure. So I'm not going to repeat how we started up. Okay. For the first version over here, we're going to get the correct implementation for deposit. However, the contract is going to be incomplete. I will explain again what incomplete really means when we see the code. So we have the bank. So now you can see that there's deposit on version 1 over here. Okay, and then deposit N, deposit into, for example, Bill or Steve, and then some amount. Okay, and then the precondition over there, we can add some precondition if you wish. And then, so now this is the correct implementation. Let me just go over very quickly. It's very easy. So now we have some local variable for dummy variable for the loop. And then we just have a from until loop over here. So from, we initialize the loop counter to be the lower bound of the accounts array. So it could be 0, it could be 1, depending on the array. But for this particular example, we assume like a Java array, so indices will just be 0. But don't forget, for IFO, just the language design choice for them. So they, by default, array indices start with 1. So you can, but usually when you're given exercises, we'll make it clear. But for this example here, indices start with 0. Okay, so, and then we exit from the loop when the loop counter is strictly larger than the upper of the accounts, right? And then we say if the current accounts we are looking at, if its owner is the same as the owner we want to deposit into. In that case, we'll simply say for that particular accounts, we're going to say deposit, which is going to increment its balance by this particular amount. A very, very easy implementation. And then make sure you always put increments to avoid infinite loop. You always make progress. Okay, so this particular implementation here is correct. Okay, now let's take a look at the implementation. So now, first of all, we can say the size of the accounts array, since we are not adding any account into the bank, so the size of the account should be the same. Okay, the first one. And then the second one, we only worry about if we want to deposit into this particular account with owner N, we only worry about that particular account. So now you can see current, the post states, current, the account of N. For example, if we want to deposit into Steve, so now we are getting a Steve's account in the post states. The balance should be its balance in the pre-states, the balance, and then plus the amount. So now I claim this to be incomplete in the following sense. This particular post condition only worry about the account being modified. But what about the rest of the bank? Maybe if we only want to deposit into Steve, what about Bill? Right? So that's why I said it's incomplete. Let's see illustration over here. Okay, so now we're going to see this. The same code I just went over, but now I want to illustrate to you. So now let's try to execute the code on paper. So for all the 5 versions, we're going to consider this particular feature call, which is b.deposit. We're trying to deposit into the bank for the account of Steve, and then to deposit $100 into Steve. So let's do a little bit preview. This is the account object for Steve. We want to deposit $100 into it. That's what the implementation will do. And once we have done that, we will reach the post states. But now let's go over very carefully about how things will do. Okay, so now in the pre-states for this particular method, so the error means we are now in the pre-state immediately before we try to execute the implementation for deposit. So we're going to evaluate this particular precondition over here. Okay, so that one will simply just satisfy because we know that Steve over here does exist in the bank. So that one will just satisfy. That's not a problem. So now, before we try to execute this particular implementation, by the way, it is correct. Before we do that, right, it is really important to remember the IFO compiler at the runtime is going to actually cache the relevant old expressions. Okay, so now it's going to cache the old expression. So now we're going to look ahead to see what should be cached, right? Let's apply your knowledge from the previous part of the lecture. So now I already highlighted for you. So this part over here, it has the old expression over here for us to cache. Okay, so now that part will be the old value for accounts.count, right? So that will be ACCS for short .count. So that should be assigned to exactly this expression over here, should be accounts.count. So currently, what's accounts.count? Simply just 2, right? Okay, so this value over here will just be 2. Okay, that's the cash value for the pre-states for this particular expression. So let's try another one over here. So now let's try this. Another expression we have to cache will be this particular one. Okay, so now you can see that one applies to all the way to the balance. So again, this is just one of the scenarios I described in the previous lecture. Please review it if you got trouble. Okay, so now how do we cache this particular one? So that one, we're going to eventually cache the balance value, which is integer. So what we'll do is, let's try, so as second variable to be cached. So it's going to be current.account of. So I'll say current.account of, and then n, and then balance. Okay, I'm just being a little bit brief over here. So now that should be assigned to over here. So what should be its value? Well, current is this particular bank, and then the account of n. So the n over here is basically Steve, right? So we talk about Steve. So current account of is going to give us this particular account objects, and what's its current balance in the pre-state? It should be 0. Okay, so now this particular cache variable will be storing 0 in the pre-state. So this, because we got 2 O expressions in the post condition, that's why we have to create 2 cache variables. I'm just trying to put everything together from what you have learned from the previous part and the current concrete example. Okay, so now we are not only in the caching process, and we have stored 2 values, 2 and 0, in the cache variables. So now we're going to go ahead and execute the implementation. We're going to execute the correct implementation over here, which is going to deposit $100 into Steve's account. Let me do that. So let's say once we have executed this correct implementation, now we are in the post states, right? This will be the post states. And the previous one would be the pre-states. So now what about the post states? This part over here is going to deposit $100 into Steve's account. So now it becomes a 100. So the post state value for Steve's account, the balance will be 100 now. So now we can now evaluate the post condition one by one, given that we also cache the values properly. Let's try one by one. What about the first one? Accounts.count is equal to old accounts.count, right? So now let me just write it aside over here. The first one over here, accounts.count. So accounts over here is a post date value. Accounts.count still remains to be 2. Equals old accounts.count. For this part over here, now we have to refer to the cache variable, right? For this particular value over here, is going to refer to this particular value over here. Okay, so now it's going to be 2. So 2 equals 2 is going to be true. So that means the very first post condition that we try to evaluate over here is simply true. So no post condition violation just yet. Okay, I'm going very slowly and thoroughly just to make sure you really understand how to put things together. Okay, so now what about the second one? The second one over there is, let's try. So now we have current accounts of and balance. Okay, so now current account of, so n is actually Steve, right? So now what's the account, current account? It is this particular account over here. The balance over here is going to give us the current balance, the post date value, which is going to be 100. 100 should be on the left hand side of the equality, equals, and then what about this particular expression over here, the O expression? So I'm going to highlight it in different color. So this is going to be old current account of and balance. Okay, what's that particular value? That particular value is exactly over here, right? That's what we cached before. So now that one should just be 0. 0 over there plus the amount, which is 100. So 100 equals 100 should be true. So that means this particular post condition that we have checked is also true. So also no post condition violation. Okay. So now please make sure you really understand the process. I'm trying to trace the code over here. You can see we have to evaluate precondition, and then we have to cache the values that's relevant for the old expression in the post condition, and then we execute the implementation to reach the post state, and then we check to evaluate the post condition using the cache variables, right? So these are the different steps that we kept talking about in the previous lecture, but now we put everything together. Hopefully it will click on you if it hasn't clicked. Okay, so that's version number 1. So basically both post conditions are satisfied, and also the implementation is actually correct. So seems like everybody is happy, but I can tell you that there's a potential danger over here, right? The fact that the the fact that the implementation is actually correct is not something we can always expect. For us as a client, we should not be optimistic. We should be pessimistic. When we sign a contract with a supplier, we should really try to be as complete as possible to make sure there's no scope of slacking off from the supplier. Okay, so now I'm going to show you in version number 2 exactly how this can happen. Okay, so now just make sure you understand version number 1, and then let's have a look at version number 2. So now for version number 2, let me just present some slides for you, and then to see what the difference is. Many things for version number 2 are similar to version number 1. Okay, for version number 1, if you simply run the test case, it's simply just going to be green bar. Okay, supplier behaves well, and also even though the contract is not complete. Oh, let me just mention one more time. What do I really mean by contract is not complete? Over here you can see this part of the contracts, the post condition, only worries about that Steve's account has been modified. However, it does not address what happened to the rest of the bank. For example, in this case, Bill. So it's going to be troublesome, as we will see in version number 2. Okay, let's move on to version number 2. Okay, for version number 2, so now we're going to still have the same contract, exactly the same post condition, but now we're going to have wrong implementation. Okay. So now for version number 2, so for this part over here, I just omit. So ... over here is simply refer to the correct implementation from version number 1. So you can always refer to that, but if you open the source code, it's there. Okay, we'll just save some space. But now what I will do is I will inject some error for the malicious supplier. So now the supplier, after doing what they are supposed to do, they do something that they are not supposed to do, which is they also try to deposit. So after depositing Steve's account with 100, they also try to deposit into another account. Let's say always the first account, in this case Bill, by the same amount. So this is not good, because if we try to deposit into Steve, we shouldn't change Bill's account, right? So now the post condition is exactly the same. So now think about the big picture. What we are having is this. The contract over here specify the obligation for the supplier for the deposit, which means if there's anything that is not satisfactory for the service provided by the supplier, and the service is implemented in the implementation part over here, if the implementation is in any way non-satisfactory, the contract should be violated, right? So now, given that we know conceptually this particular extra line introduced something that's not acceptable, so we would expect whatever contract you have currently should be able to give you some post-condition violation. But is it going to be the case? If it is, that means we're done. It is satisfactory. If it is not going to give you a post-condition violation, that means your current contract is incomplete. Okay, let's have a look to really judge to see whether that's really incomplete or not. Okay, let me switch to the second version over here. So now, in order to trace it, I'm still going to go through the entire process, but I'll be a little bit briefer this time. Okay, so now we're going to check the precondition. Okay, it will be satisfied. And now in the pre-states, we're actually going to cache the two values as before. Okay, so now it's going to be cache this particular value over here, and also to cache this particular value over here. Just make it briefer. Let me say this is variable 1, this is variable 2. So variable 1 is going to evaluate this particular expression at the runtime in the pre-states. And as we said before, it's going to be 2. Okay, the same process. I don't need to repeat. And also for variable number 2, it's going to cache as before, is going to be 0. Okay, so now these are the cache variable. And then we execute the correct implementation first before we do the error. Okay, so now we are still, well, by the way, we are still trying to deposit $100 into Steve, right? So now this particular implementation here, that's correct, right? This is correct, and this part is incorrect. Let's execute the first part. The first part is going to deposit $100 into Steve's account. That part is fine. However, this incorrect part also try to deposit into the first account in the bank, which is Steve. Oh, sorry, Bill. Over here. So we're also going to deposit $100 into it. So now the supplier has done something that's unacceptable. So now the question is, are these two post conditions going to give us any violation? Let's see. Let's check very quickly. So now when we check the first one over here, let's say when we evaluate this particular condition over here, okay, this one here. So now the account is still 2. And then this particular cache variable is actually 2. 2 equals 2 will give you true as before. And now if you try to evaluate this particular post condition over here, what's it going to be? The left hand side is going to be current account of and the balance, right? It's referring to the post state bank. So now it's going to be the current account of, so now this will be Steve, right? So Steve is the parameter n. So now what's its balance? It should be 100, right? So 100 should be on the left hand side, equals, and then this part over here, and now this is referring to the old states, the cache variable, and also it's 0. Equal to 0 plus the amount should be just 100 over here. Okay, we still get true. So we get true and true. So there's no post condition violation. So this is the conclusion. We know that the implementation over here is wrong. Implementation is actually wrong. And the post condition are all satisfied. So no post condition violation. So combine these two facts together, so that means it is not satisfactory. Because recall what we said in the very first lecture, what does it really mean for design to be good? That means when something goes wrong, there should be exactly one party to blame. But now, because no counter violation, no party is to be blamed for the wrong implementation. So that means our post condition over here is incomplete. We should have also thought about not only that Steve's account should be changed to 100, but also the rest of the bank, for example Bill, it shouldn't be incremented, it should remain to be 0. That's the problem. That's why I said for the second version here, the incomplete post condition cannot catch the error that's caused by the wrong implementation. Okay, so hopefully you get the idea for the first two versions. So what we should do, starting from version number 3, is we have to make the post condition complete by adding one more post condition. And the extra post condition we're going to make will be like a universal quantification. We want to go over every account in the bank. If the current account is not the one we try to deposit into, for example, we go over the account, we go over index 0, index 1, etc. Right? If the current account, the owner is actually not the owner we are trying to deposit into, so that would mean the account balance should be the same. If they are not the same, that means the supplier has done something that's wrong. So, and then we should really produce a post-condition violation. That's going to be what's going to happen in the 3 versions. And then the 3 version, the only difference is what kind of copy should we make of the pre-state? Should we make a reference copy, shallow copy, or deep copy? We're going to see the consequence of making each one of them.